Hello guys, our today's topic is the periodic table, exploring how elements are arranged throughout the periodic table. Lesson outline: we'll learn about electronic structure of an atom and the features of periodic table. Learning outcome: you'll be able to explain the features of periodic table of an element, draw the electronic structure of elements with the help of periodic table, recognize and predict properties based on the trends of the periodic table. Keywords: atomic number is the number of protons present in an atom, and in the neutral atom the number of electrons it is equal to the number of protons. You have to remember this. The next is atomic mass or the mass number. It is the number of protons and neutrons present in an atom. Now we'll study the structure of an atom beyond what we can see in the periodic table. We'll look at the element's electronics. Electronic structure illustrates the electron arrangement of an atom of an element. That is, how the electrons are arranged is the electronic structure. Below here you can see the structure of an atom. The Y represents nucleus, which has protons and neutrons in it, and the X represents the electrons. They are revolving around the nucleus in energy shells or electron shells. These green circles are the electron shells and these X marks are the electrons. The first energy shell is called K shell. The second energy shell is called L shell. Third is called M shell and fourth is called N shell. There are some rules when we are drawing the electronic structure of an element. In the first shell, that is the K shell, only 2 electrons can be filled, not more than 2. In the second L shell, only 8 electrons can be filled. Similarly, in the third shell, M shell, only 8 electrons can be filled. And in the fourth shell, that is the N shell, 18 electrons can be filled. And mind it that when the first shell is not completely filled, you cannot start filling the electrons in the next shell. So first shell has to be completed in order to move to the second shell. Similarly, second shell have to be fully filled in order to go to the L shell or the third shell. Now, for example, oxygen atom. Oxygen has an atomic number of 8. Atomic number means number of protons. Now, in a neutral atom, I told you that number of protons, it is equal to the number of electrons. So, number of protons are 8. So, number of electrons will also be 8 in a neutral atom. Now, there are 8 electrons we have to fill. First, in the first shell, we can fill 2 electrons. In the K shell, we saw in the rule that 2 electrons can be filled. In the second shell, rest of the electrons will be filled. In the first, we already filled 2 electrons. 8 minus 2, there are 6 electrons left. So next shell will be having 6 electrons in it. So the electronic configuration will be 2 in the first and 6 in the second. What is the shorthand notation we can write for writing the electronic configuration? In a bracket, we write 2 in the first shell, then comma, 6 in the second shell, and then we close the bracket. Or we can write as 2.6. 2 in the first shell, 6 in the second. Each dot or comma separates the one shell from the other. Now there's a learning check for you. Please draw the electronic structure for lithium, sodium and potassium and write the electronic configuration for each element. On the right hand side, you can see lithium, sodium and potassium with their atomic numbers written on the top side. If your answer is 2.1 or 2.1 for lithium, you are correct. In the first K shell, 2 electrons will be there, and in the L shell, 1 electron will be there. For sodium, 2 electrons in the first shell, 8 electrons in the second shell, and 1 electron in the third shell. You are correct. Then in potassium, 2 in the first shell, K shell, then L shell, 8 electrons, in M shell, 8 electrons, and in N shell, 1 electron. Then you are correct. Now moving on to the periodic table. Periodic table is also called as the map of chemistry. The elements are arranged in the increasing atomic number, that is the number of protons. Periodic table of elements. It contains the atomic mass, atomic number, and chemical symbol associated with the known element. As of today, there are 118 elements in the periodic table. This picture represents the periodic table of elements. In this picture, there are 118 elements which are known till date. And you can see a man is standing there with a magnifier. He is trying to look at the element. Now let's see what you can see inside an element when you see it in the periodic table. This 11 represents atomic number, which tells us about the number of protons in an atom. 22.989769 represents mass number, which tells us about the number of protons and number of neutrons present in the nucleus of an atom. This Na is the chemical symbol of the associated element. So in short, from a periodic table, you can come to know about the atomic number of the element, the chemical symbol of an element, and the mass number of an element. If you see a periodic table, you can also tell about the metal or non-metal about an element. How you can do that is, if you see the boron, which is B, below boron comes aluminium. Starting from aluminium, if you go in a stairway, that stairway is nothing but a transition from metals to non-metals. So everything left to the staircase is metals, and everything which is right to the staircase is non-metals. So you can clearly tell, if you have a periodic table in your hand and someone gives you an element to find out whether it is a metal or not, you can just refer this staircase, and left to that staircase will be metals and right to that staircase will be non-metals. Features of the periodic table. A row is a period. Each element's atomic number increases as you move along the period. So this going from left to right is called a period or a row. We usually term it as a period. So in the period 1, there are only two elements, H and He, that is hydrogen and helium. Similarly, period 2, period 3, and so on. There is a question for you. Can you tell which is the period highlighted. Pause the video, think, and then answer. If you answered period 4, then you are absolutely correct. A column is called a group. Elements in the same group all have same number of valence electrons in their outer shells. If we see that this hydrogen, lithium, sodium, potassium, rubidium, cesium and francium belongs to group 1, this means that all the elements in group 1 will be having same valence electrons in their last shell. Similarly, this is group 2. This you don't count it right now. This is group 3, 4, 5, 6, 7, 8 or group 0. So all the elements in group 3 will be having same valence electrons in their outer shell. Question time for you. Can you tell the group number which has been highlighted? Think, pause, and then answer. If you answered that this is group number 4, then you are absolutely correct. Or group 8. We usually call it as group 0, not 8, because helium has 2 electrons. So in the first shell, 2 electrons are filled. Whereas group 8 means that there are 8 electrons. Therefore, we name it as group 0 rather than naming it as group 8. Group 8 or group 0, in this group, everything is filled. That is, all the electrons in the outermost shell are completely filled. So, in case of helium, there are only 2 electrons. That is why 8 is not appropriate for this. Hence, we call it as group 0. Now, there are few things that you have to remember. The group number tells you the number of electrons in the outermost shell. If group 1 is there, any element from group 1 will represent 1 electron in its valence shell. Similarly, if it is group 6, then the outermost shell will be having 6 electrons. All the elements in the group 6 will have 6 valence electrons. The period number tells us about the number of electronic shell or the energy shell. So suppose if an element is in the group period 3, it means that there are 3 shells. All the electrons will be filled in the third shell only. Now comes the electronic shell. What is electronic shell? Electronic shell is the energy level outside the nucleus which has electrons in it. And electronic configuration is the arrangement of electrons in an atom. There's a question time for you. The electronic configuration of fluorine is shown. What group is fluorine in? Group 4, group 7, group 8 or group 1? Pause, think and answer. If you answered group 7, then you are absolutely correct. Well done. It means that there are 7 electrons in the valence shell. 1, 2, 3, 4, 5, 6 and 7. Hence, it has group number 7. Now, we did one question in the starting where we wrote electronic configuration and drew the diagram of an atom for lithium, sodium and potassium. Can you figure out what is same in all the three? Pause the video and think. If you told that all of them have one electron in their valence shell, it means you are correct because all of these elements, lithium, sodium, potassium, belong to group 1. So, all the elements have one electron in their valence shell. So, you can check from here that the atomic number increases down the group. The atomic number tells you how many electrons each element has. Each group 1 element structure has one electron in its outer shell. Elements are grouped together by the number of electrons that they have in the outer shell. Summary. The modern periodic table organizes elements by atomic number, revealing their structural arrangement. Elements' positions in the periodic table reflect their atomic structure and outer electron arrangement. You can check out YouTube Shorts or Instagram page for more questions related to periodic table. Thank you.